Okay, the prediction is very easy. I think everybody understands. We get 1.1, 0.9 here. Our slope is -1. We go over 1 unit, we're going to, or 0.1 unit, we're going to have to go down 0.1 unit, which will take us from t equals 1 to 1.1, and y from 1 to 0.9. Now, how accurate is that? In this case, we can easily solve this equation and find our function y. Okay? This is solvable. This is also solvable, but you don't have the techniques for solving it yet, and that's why we're taking a differential equations course to trick these more tricky equations into giving up their solutions, right? Now, if you can't trick them into giving up their solutions, you can always do this with a sufficiently small increment and get a good approximation to your actual solution. Okay? Okay, well, in any case, this is solvable. Okay? And we actually, in physics yesterday, since you were both there, we actually solved it yesterday, except we had a k in front of the square root of y. So the solution is very simple. You have dy over square root of y equals -1. Right? So that 2 square root of y equals -t plus a constant. So that y equals, well, -t plus a constant quantity squared, right? So that's going to be t squared over 4 plus, minus 2ct plus c squared. Where c is an arbitrary integration constant. Now, what is the value of c? If we want to model the function that we get when we start from this point, 0.11, this tells us that when t equals 1, y has to equal 1. Well, if t is 1 and y is 1, what does your value of c have to be to make these two equal? In other words, we just plug in 1 for t and 1 for y, and we get an equation for c. So what's our value of c?